This homework question from section 2.5 came in from a student. Thank you for sending this. Let's look at how to use polynomial long division to find an oblique asymptote. If you recall from pre-calculus, using long division, we're going to write the numerator inside the bracket. So this 4x cubed plus 12x squared, so one goes inside the division bracket. And the denominator, the 2x squared plus 2, becomes the divisor. It's outside the bracket. And when we go to do the long division, do you remember that what we're doing is we're taking this 4x cubed and dividing it by the 2x squared. When I do 4x cubed divided by 2x squared, and I'll actually write that off to the side like you see I have it written here. And when we do that division, we get 4 divided by 2 is 2, x cubed divided by x squared is x, so we get 2x. So I'm going to write the quotient 2x right here above the linear term, right above the 6x. After you divide, the next step is to multiply. So I'll take this 2x squared plus 2, and I'm going to multiply that times our 2x, right? Really what I'm going to do is I'm going to distribute the 2x. When I distribute the 2x, I get 4x cubed plus 4x. 2x times 2x squared is 4x cubed. 2x times 2 is 4x. And I'm going to write that product here, 4x cubed plus 4x, except I've got to be mindful to write the 4x under the linear term, so under the 6x. And then this next step is where students who are going to make a mistake are most likely to make the mistake here, because I'm now going to subtract 4x cubed and subtract 4x. So you have to remember to distribute that negative to both the 4x cubed and the 4x. Now, if you think through, why am I subtracting here? Why did I divide? Why did I multiply? If you go back to an old-fashioned long division problem, do you recall this? I would do 35 divided by 27 is 1. That was the division, and that's what I did here. And then I would say that 27 times 1 is 27. That's the multiplication. And then I would do the subtraction, right? I would subtract 27 from 35. To get 8. That was subtract. And then the last step is I'd bring down this 7. Transfer that over to our polynomial division. I did the division, got 4x cubed divided by 2x squared is 2x. Here's the quotient. Wrote the quotient as part of the answer. Did the multiplication and got 4x cubed plus 4x. And then I'm going to do the subtraction. When I do the subtraction, I'm going to have to say that it's as if we have a 0 here, right? So that 12x squared minus 0 gives me a 12x squared. 6x minus 4x is minus 2x. And then I can bring down this plus 5. Let me erase this multiplication so that I have room to continue here. Now I'm ready to start over, and I've got 12x squared divided by 2x squared. 2 goes into 12 6 times. X squared over x squared is 1, so I get 6. So the next part of my quotient will be plus 6. Multiply the 6 times the divisor. So in other words, distribute the 6 to 2x squared plus 2. and that's going to give us 12x squared plus 12. I'm going to subtract 12x squared and subtract 12. So don't forget to distribute those. And I'm going to get a negative 2x. 5 minus 12 is a negative 7. This remainder has a smaller degree than my divisor, so I'm done. And this this expression I have now as the quotient is what we would call our oblique asymptote. We didn't go over this in class because this part, this long division and the finding an oblique asymptote, is actually a pre-calculus topic. That's a review from pre-calculus. But here it is for you in the case you didn't remember any of that. Part A, the oblique asymptote is y equals 2x plus 6. Part B, find the vertical asymptote. We find the vertical asymptote when the denominator, 2x squared plus 2, is equal to 0. For this example, if I solve this for x, I'd subtract 2 from both sides and get 2x squared equals negative 2. It doesn't show up very well, does it? Let me change the color. And after I have the 2x squared equals 2, divide both sides by 2 to get x squared equals negative 1. Remember, I'm solving for x, so I'll do the plus or minus square root of both sides. And I get the x's, the positive or negative square root of negative 1. Problem with that is that the square root of negative 1 is not a real number. So what I could say is that there are no vertical asymptotes. There's no value for x that makes this denominator a 0. So for part B, we'd say that there are none. Finally, for part C, if I wanted to graph this, and it is multiple choice, I don't have the multiple choice options here, but here's what I would be looking for in those options. I'm looking for an example that does not have a vertical asymptote, but that does have this asymptote y equals 2x plus 6. If I were to graph y equals 2x plus 6 as an asymptote, I'd get something somewhat like this. Right here's my oblique asymptote. And so I'm going to look for the only graph out of those 4 choices that has that oblique asymptote. You could use a graphing utility to get a more precise graph, but you don't need to. All you need to do is pick the multiple choice option that has that asymptote graphed. I hope that this helps you, but if you do need further assistance with this problem, please don't hesitate to contact me.